So as you can see, today's our topic is chromatic polynomial. Already we draw here a graph G and we have to find out the chromatic polynomial of this above mentioned graph G. Now look at that. This is the formula of any graph G. What is the chromatic polynomial? Now first you have to find out what will be the chromatic number, which we already discussed in the previous videos. So first we have to find out the chromatic number. Then what is the definition of this chromatic number? Minimum required color to color a graph, right? Now suppose a vertex we will mark it with blue. Then as A is connected with all other vertices, so we can't put anywhere this blue color. That means we have to put any one of the another color to this C. We will put here red color. Now as we put here red, C and D are not connected, so we can put there red. Similar way, if we put here white, then we can put there also white. So what is the chromatic number of this graph G? Chromatic number of this graph G is 3. Clear? Now what is written there? This is the formula of the chromatic polynomial, right? If we expand this, now look at this, n is the number of vertices. If we expand this for this graph G, so what we can write down? C1 X composition 1, C2 X C, C2 C3. Right? Is it clear? Now look at that. What is the chromatic number of this graph G? That is 3. So one color is not required to cover this graph, and also two color is not required to cover this graph, right? That means C1 equal to 0 here, also C2 equal to 0 here. Clear? Now C3. C3 means we have to require minimum 3 colors, right? 3 colors. Out of 3 colors we have to choose in how many ways? That is 3 factorial ways. So C3 equal to 3 factorial. First we have to write down 3 factorial, that is 6. Clear? Now C4. C4 means you have 4 colors, but actually you have needed how many colors? You have just needed 3 colors, right? Now first we will put 3 different colors to 3 different ways. Or suppose first we have 4 colors. We can choose a vertex, any one of the color. How many ways? 4 ways. There is no other options. As we will put or assign any one of the color to this A vertex, then B can be choose how many ways? 3 ways. Now C can be choose in how many ways? 2 ways. Clear? Now we have remaining 2 vertices. What are they? D and D. Now we are considering the 4 colors. So for D vertex we have 1 more color is extra. So we can put any one, either another 1 color, that is, suppose here we use the blue, red and white. Suppose green. Green, if we put D, this is one choice, or we can put green to E. That means there are 2 choices. So how many choices we will actually get? 4 into 3 into 2 into 2. That means 48 ways. Clear? Next, C5. C5 means we have 5 colors at a time. So 5 colors can be chosen in how many ways? 5 factorial ways. That means here we can choose 5 colors. Here we have to choose 4 colors. 3, 2, 1. So 5 factorial ways. Now put these values and we can get the polynomial. So what will be the polynomial? C1 is 0, C2 is 0. Put the C3 value, right? XC3. This is the composition x into x minus 1 into x minus 2 by factorial 3 plus 48 into x minus 1 into x minus 2 into x minus 3 by 4 factorial plus 5 factorial into x minus 1 into x minus 2 into x minus 3 into x minus 4 divided by 5 factorial. Now just we have to calculate and we will get the chromatic polynomial of the following graph. And finally we will get the answer, that is this cancel out, 4 will be cancel out, we will get 2, this will be cancel out, right? Now just we have to simplify this. Already you can take this is as a common, x into x minus 1 into x minus 2, that is 1 plus 2x minus 6, right, plus x square minus 7x plus 12, right? Okay, now just calculate these terms and you will get the answer. So that will be the answer, right? This is your required polynomial.